Okay, this is 2.3 Polynomial Equations. A lot of what we're doing here is using our factor theorem, our integral zero theorem, our rational zero theorem in order to factor polynomials. Why? Because a polynomial that can be factored can give you a lot of information. It gives you the roots, which means it gives you the x-intercepts, okay? Which allows you to draw it or to apply it to real-world situations if it is indeed modeling a real-world situation. So we start here with a little bit of just a reading warm-up little thing in order to get our heads into the game. It says, suppose the volume in cubic centimeters of a block of ice that a sculptor would use. Let's say it's modeled by the volume with respect to x is 9x cubed plus 60x squared plus 249x, where x is the thickness of the block in centimeters. What maximum thickness of wings can be carved from a block of ice with such and such volume? So in order to do that, we were given the volume of ice that we're working with, and now we have an equation that we can solve. It's a cubic equation, but the only variable there is x, and so we can solve it. So all we're going to do then is work through the examples after a brief note-taking and solve these things. In order to solve, it basically means you're factoring, okay? Here's notes. When a polynomial function is given in factored form, you can identify the zeros of the function and you can identify the x-intercepts of the corresponding graph. So we've done activities before where we've talked about, okay, what's the most helpful form to have things in? And when you're talking about quadratics, factored form is pretty helpful. Vertex form is also pretty helpful. But in any polynomial, quadratic or higher degreed polynomials, if it's in factored form, you know all of the zeros, which correspond to this, they are the solutions of the equation. And you can also identify the x-intercepts of the corresponding graph. So you get a good idea of what it looks like. Then, for a polynomial function, y equals p of x, where p of x could be any polynomial expression or function, just like we had up in the original word problem about the ice sculpture. You had v of x, it was this long cubic. Okay, so for any polynomial function here, the roots are determined by letting y equal 0. So basically you set that polynomial expression equal to 0 and then solving. Where does p of x equal 0? That will get you the solutions. Sounds like a lot of words, sounds tricky. It's actually in application really familiar. All right, example 1, solve polynomial equations by factoring. Example 1, in A, we are given the polynomial equation x cubed minus x squared minus 2x equals 0. So it's already set equal to 0. So in solving for x, we're going to be finding the values of x that make this statement true. In order to do that, we're going to be factoring. So step one, do you see anything that we can factor from every term on the left? Yeah, we can factor x from each term. That's easy. That's going to take us from a cubic to a quadratic right off the bat. So now we've got x on the outside and inside the bracket, x squared minus x minus 2. And now since inside the bracket is just a trinomial quadratic, we can factor that fairly straightforward. Factor the trinomial. So we've got x on the outside, and now I'm looking for two numbers that add to -1, multiply to -2. So we've got x minus 2, x plus 1.
We can just do that.
Yep, when it's a simple trinomial quadratic and the leading coefficient is 1, it's really easy to just split it up that way. And you can always double check by multiplying it back. I have x squared. If I do outside times outside, I've got 1x. Inside times inside, I've got -2x. Well, they add up to be -x. And last times last would be -2. So once we're here, I've got three terms, three solutions, because I have three factors here. One factor here, one factor here, one factor here. Since they're all multiplied by each other, which is why they're called factors, only one of them needs to be 0 for this statement to be true. So if x by itself equaled 0, then whatever ends up being the value of these two factors together, I'm going to multiply it by 0, which is going to give me 0. So x equals 0 is a solution. Or this middle factor could be 0, in which case x equals 2 is a solution. Or this last factor could be 0, in which case x equals -1 is a solution. Okay? So what we would do here is we would write the little word or, and that's our solution. Okay? All right, could put a little box around what we got here. Could have rewritten it nice and neat somewhere. But that's really it. You're factoring and then finding the solutions based on those factors. Okay? In B, we are given a cubic that has a constant at the end. We've got 3x cubed plus x squared minus 12x minus 4 equals 0. Notice it's already set equal to 0, so I can simply follow the steps that I know in order to solve this. And one of the strategies for solving a cubic with 4 terms is to factor by grouping. So the first thing I'm looking for is pull out an x if I can. If I can't do that, I'm looking at factoring by another means, which in this case is going to be factoring by grouping. And if I can't figure that out, then I'm looking at the factor theorem in order to help me develop that first factor to help me divide out this polynomial. But I see here right away the coefficients. The relationship between 3 and 1 is the same as the relationship between -12 and -4. So that's a big clue for me that I can actually think of this in terms of groups. Group here and a group here. And that I can then factor by grouping, okay? So I'm just going to be looking at these first two terms. What can I factor out of them? I can factor x squared out of them. If I do, that's going to leave me with a factor of 3 and a factor of x. And if I factor x squared out of x squared, I just have a factor of 1. Essentially, I have nothing left. With these next two terms together, I can factor out -4. That's going to leave me with 3x plus 1. A really good quick check that you've done it right, or that it was a good opportunity to factor by grouping, is now I have two terms, and those terms each have a common factor of 3x plus 1 in this case. So now I can look at those two terms. They both have a 3x plus 1, so I can pull 3x plus 1 out. When I do, in the first term I'm left with x squared, and in the second term I'm left with negative 4. Still set equal to 0. And now I can see, what do I have here? Difference of squares, which I can factor into the product of a sum and difference. It becomes x plus 2, x minus 2. It equals 0. There's my 3 factors. So our solution, a solution that comes from the first term, a solution that comes from the second term, and a solution that comes from the third term. If any of these factors is 0, the whole thing would be 0. So simple algebra over here, we're going to subtract 1 from both sides and then divide by 3. We're going to end up with x equals negative 1/3 as a solution. Over here, we're going to subtract 2 from each side. We end up with x equals negative 2 as a solution. And here, adding 2 to both sides, x equals negative 2 as a solution. I put the word or in those. Why do we use the word or instead of and? X can't be two things at the same time. So it can't be negative 2 and 2. But as you move along the graph, let's say, you can come to the position of x equals negative 2, or you can move along to x equals 2, or you could be at x equals negative 1/3. And those are all solutions, okay? Good, good. So again, the first one we factored out the x, really easy. That's step 1, look for the x. Next one we factored by grouping. The next one we're not going to be able to do either of those things. In example 2, we're going to be using the factor theorem, okay? So in example 2, we're asked to solve 2x cubed plus 3x squared minus 11x minus 6 equals 0. Okay, it's already set equal to 0. That's very nice of them. We'll get into problems where you'll have a value on the other side. What we have to do, you'll have to get that stuff all to the other side using proper algebra so that you only are left with 0 on the one side. But I look at the relationship between my coefficients. There's nothing that makes it obvious that I can factor by grouping. And so I turn to my factor theorem. And are we going to be using the integral 0 theorem or the rational 0 theorem? The key is this value right here, okay? If the leading coefficient is not 1, then you're looking at the rational 0 theorem, which is essentially just the same, but it's explained differently so that it's easier to apply to rational numbers. Really, the integral 0 theorem could be just explained as the integral 0 theorem, where the denominator is 1. Anyway, in this case, we're going to apply rational 0 theorem. If you need a refresher on that, you can check the last video. And what does it say? Well, it says that, maybe I'll flip back to help you. It says that p of x has factors of ax minus b if p of b over a equals 0. Okay? So a of ax minus b is a factor if p of b over a equals 0. Where do we get b and where do we get a from? Well, we get b from the factors of our coefficient, and we get a from the factors of our constant, and a from the factors of our leading coefficient. So all we're going to do here is note our possible values for b. So our test values for b. And they come from the factors of negative 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And our test values for a come from our leading coefficient. So the factors of 2, that could be plus or minus 1 and plus or minus 2. So now when we're using test values in order to determine one of our factors, we're going to start with a pretty easy 1. We're going to start with our easiest ones, really. And I'd usually start in positive land. But basically what we also want to identify then are the test values for b over a. This indicates the value that we're going to actually put into our function and find out what the remainder is. So b over a is any of these numbers over any of these numbers. Okay, so you have plus or minus 1, that's 1 over 1. You've got plus or minus 1/2, that's 1 over 2. 2 over 2 is the same as plus or minus 1, so I don't have to rewrite that. Then we've got plus or minus 3 over 2. We've got plus or minus 3 because that's 3 over 1. We've got plus or minus 6 because that's 6 over 1. And we've got plus or minus 6 over 2, which is just 3, which I already have listed. Okay, so these are our test values. I'm missing one. We need plus or minus 2 because 2 over 1 is 2. So now when we're working through this, we would test. Let's test positive 1. If I throw positive 1 into p of x, I'm just going to do it in my head, but we've got 2 times 1, that's 2, plus 3 is 5, and then I have negative a whole bunch, so that is not going to be 0. So therefore, x minus 1 is not a factor. Again, if you're on your practice problems and you know how to do this, you wouldn't have to write that statement, but it's just good for a quick review. Then I could put negative 1 in, or I could put negative a half in, or positive a half, but I'm going to jump right to 2 because I like working with whole numbers and because I know it's going to work. So here we can do it in our head again a little bit. I've got 2x to the power of 3, that's 2 times 8, that's going to be 16, plus 4 times 3 is 12, minus 11 times 2 is 22, minus 6. So I've got 28 negatives and 28 positives. That does equal 0. If the remainder is 0, then the polynomial is divisible by the corresponding factor. So x minus 2 is a factor. Okay? So I have one of the factors of our polynomial. How do I get the other factors? I'm going to set up a synthetic division. Okay? Set up synthetic division to find other factors. So my synthetic division grid, you've got the value minus 2 here because that comes out of your factor. Your factor is x equals 2. So we pull out the negative 2 there, put a negative symbol here, put a multiplication symbol here. We're going to record the coefficients of the polynomial. That's 2, 3, negative 11, and negative 6. And then we're going to perform our synthetic division. Essentially says take down the first coefficient and then multiply negative 2 times 2, that's negative 4. 3 minus negative 4 is 3 plus 4 is 7. And then we got negative 2 times 7. By the way, if you can't recall, this is following the steps of long division using just the coefficients, and it's better explained in the last video. Negative 2 times 7 is negative 14. Negative 11 plus 14, that's positive 3. Negative 2 times 3 is negative 6, and this is the confirmation that we got it right. If we end up with a 0, then we know that's our remainder. And what does this tell us? This tells us that p of x has a factorization, not a full factorization, but it's x minus 2 times, and this is just our coefficients, but we know we factored out one factor of x. So all of our exponents here are going to drop 1 degree. So we're looking at 2x squared plus 7x plus 3. Okay, it's not done yet. We have one factor pulled out, and we have the polynomial that is still remaining. And now we still need to factor out this one, okay? So we can factor that out by, again, factor by grouping is what you want to do. And you want to use sum and product to split the middle term. I'm not going to show that because we should be fairly comfortable with that. Instead, I'm just going to rewrite that factorization all completed. So we've got x minus 2, and then the factorization of this, if you work through it, is 2x plus 1 times x plus 3. And now to solve, we would set this whole thing equal to 0. Maybe I'll make a note of that. I'm going to come on over here. You could keep working down if you have space. To solve, set p of x equals 0. For you, by now, that's probably your natural next step. You probably do this part in your head. But basically, we've got 0 equals now our factorization of p of x, which tells us that the solutions are x equals 2 or x equals negative 1/2 or x equals negative 3, and each of those comes from one of the factors. Okay. Then B says take that answer and tell what does that represent in terms of the related polynomial function. So what are these actually? What information does that give us? They are the roots of the equation y equals p of x. That's not right. They're the roots of the equation, the original equation when it's set equal to 0. So this last step right here, that's what gets them the roots of that equation. And they are the x-intercepts of the corresponding graph. Okay, so far we've only solved equations, we've only worked with polynomials that only have real roots. That means the x-intercepts or the roots or the solution are real numbers. But you can also have non-real roots. Okay, let's look at that. A note at the bottom of page 15. Maybe draw a little line underneath the work that you've done to show that this is kind of a break in the section. Polynomial equation. Polynomial equation may have real and non-real roots. Consider x minus 3 times x squared plus 1. Okay? The roots here are, for the first factor, x equals 3. For the next factor, it's x squared equals negative 1. Can you, or, watch this, another way to think about it, x equals, if I square root both sides, the square root of negative 1. Okay, plus or minus the square root of negative 1. Can you think of any value that you can multiply by itself to get a negative value?
Nope.
It's impossible. A negative times a negative is positive, and a positive times a positive is positive. So there is no such thing as the square root of negative 1. Okay? Since the square root of a negative number,
How do they show up on a graph? Just maybe an area there?
we'll draw one. Since the square root of a negative number is not a real number, the only real root is x equals 3. Okay, so this graph, it is still a cubic. It says 3 factors of x. It looks like a cubic, but it only has one x-intercept, which is fine. I'll just draw what this, what the corresponding graph looks like. So maybe just, I don't know if you have space for this, but graph of y equals x minus 3 x squared plus 1. Basically, you have your y, your x. It's just a quick sketch, but we have one real root at x equals 3, and there are no other roots. So this one kind of looks like this. Okay, you'd never know by looking at it, but it is still a cubic and it only has one root. So it's only going to cross the x-axis once.
That's interesting.
In example 3, we're looking back at that chunk of ice that we used at the beginning in order to carve out some dragon wings. And the volume V is given by V of x equals 9x cubed plus 60x squared plus 249x. But we're also told that the volume of ice that we're given is equal to 2,532 cubic centimeters. So what do we have here? Well, we have an equation. We need to solve the equation. The equation what? Well, we know that the volume is 2532. So all we have to do is set our polynomial expression 9x cubed plus 60x squared plus 249x equals 2532. But we said we can only solve things when we have 0 on one side. So we need to subtract 2532 from both sides. So the first step here would be to get 9x cubed plus 60x squared plus 249x minus 2532 equals 0. Now I can't see anything in there that I can factor out immediately. I might try a couple of numbers. I would first try this leading coefficient. If I could factor that out, that'd be great, but I know 60 is not divisible by 9. But the factors of 9, 3. Is 60 divisible by 3? Yep, that's 20. Is 249 divisible by 3? Do you remember the rule for divisibility by 3? If the sum of the digits is divisible by 3, then the whole number is divisible by 3. So 2 plus 4 is 6. That's 15. That is divisible by 3. And same thing here. I get 7 plus 5 is 12. That's divisible by 3 as well. So my first step is actually going to be to factor out the 3 from every term. factor out the common factor of 3. So that's going to leave me with 3x cubed plus 20x squared plus 83
Yep.
x
Subtract 849.
844 844
Yep.
equals 0. Well, now it's still pretty ugly. I don't see any factoring by grouping. I don't see any other common factors that I could pull out. So we're looking at the irrational zero theorem, in which case I'm going to have a long list of possible B's and A's. Okay, the B's come from factors of 844, which would be like plus or minus 1, plus or minus 2 because it's even. It's not divisible by 3, is divisible by 4 because 800 is divisible by 4, 40 is divisible by 4, and 4 is divisible by 4. So is divisible by 4, not divisible by 5. Is it divisible by 6? In order to be divisible by 6, it has to be divisible by 2 and 3, so it's not divisible by 6. Is it divisible by 8? 800 is, but 44 is not, so it's not divisible by 8. My assumption is that it's not divisible by 7. Is it divisible by 9? No. 10? No. And basically you could keep trying to go here, but I think we're on the top of the mountain already. Do you know what I mean when I say we're at the top of the mountain, we're heading back down?
211.
Yeah, but so
It's a big number, but
yeah. So 211 pairs with 4. So 211.
yeah.
And when I divide it by 2, I end up with 422. And when I divide it by 1, you end up with the number itself, 844. So those are the possible values of B. Possible values of A come from the leading coefficient, which is 3. So we're looking at plus or minus 1, plus or minus 3, which
Is
means
211 a prime number? Pretty sure it is.
for B over A, we're looking at values of plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3. Okay, and I'm not going to keep going. You get the point. 211 over 3 would be the next set. So when you choose a value, again, start with the easiest value that you have. I'm going to cheat and just pick a value that I know works. I'm going to sub P of 4. I find out that that equals 0. Therefore, x minus 4 is a factor. Again, I'm not showing all the work here. We're just demonstrating. So what would you do now? You would divide out x minus 4 by this factor right here, the long trinomial inside the brackets, using synthetic division or long division. And what would you end up with? You would end up with v of x. I should put a v here, not a p. V of x is equal to x minus 4, which we factored out, and the remaining factor would be 3x squared plus 32x plus 211. Okay, so then we need to solve where this whole thing equals 0, so I would still need to factor this out. If you look at this quadratic, you could probably, it's possible that you could work for sum and product on this thing, but what do you do when it's confusing and you don't know what to do and it's a quadratic that you need to solve? Again, if you tried sum and product, you can't get any whole numbers. So then what would you do?
You would factor by grouping.
It's not factorable.
211 is a prime number, so I forgot. I think I mentioned that. If you want, you can factor 3x squared and 32, right? Yeah, okay.
We're going to use the quadratic formula here. And quadratic formula says, and I'm going to I'll just keep doing it over here. X equals negative b, which is negative 32, plus or minus square root of b squared, 32 squared, minus 4ac, which is 4 times 3 times 211, all over 2a, which is 6. If I reduce that, we end up with negative 32 plus or minus, and then under the radicand here, we end up with 32 squared minus this whole chunk becomes negative 1508, and still over 6. Now, what is the problem?
It's negative.
Okay, so when we were dealing with quadratics, we said if there was a negative under there, there were no real roots. Same thing here applies. Since the square root of a negative number doesn't exist, no roots that come from this situation would be real roots. You could get an imaginary number, because it'll have the square root of -1 when you factor it out or whatever, you work through it. But no real roots will come from this. Okay? No real roots will come from this. So we can, let's kind of keep going here. Since no, let's not do this. We'll just say right over here, no real roots because of this negative sign here. So we can say the only real root is x equals 4. Okay, let's go back to our word problem, see what we were actually finding. What maximum thickness of wing can be carved from the block of ice with this volume, where x is the thickness of the block in centimeters? Should say is the thickness of the wing in centimeters. So the max thickness of the wing is 4 centimeters. Therefore, max wing thickness is 4 centimeters. Okay, so we were given a function for the volume with respect to x. We were told that the volume of the block of ice is 2,532 cubic centimeters, so we set them equal to each other. We subtracted 2532 from each side so that we would have it set equal to 0, and then we used all of our brains in order to solve it, first by factoring out a common factor, then by using integral zero theorem in order to get x minus 4 as a factor. The quadratic that was left was not factorable, so we used the quadratic formula, but we realized that there were no real roots coming from that trinomial, so we conclude that the only real root is 4, therefore the wing thickness, max wing thickness, is 4 centimeters. Okay, example 4 says determine the roots of a non-factorable polynomial equation. So we've got x cubed minus 3x equals -1. We're going to follow the same steps we always do. We need to set it equal to 0, so we're going to add 1 to both sides. And then if we apply our factor theorem, we get the factors of 1 are -1 and +1. The only factors, the only potential values for b are positive and -1. But look at what happens when we test those. If we test p of -1, we get -1 cubed, which is -1. -3 times -1 is +3, and then we add 1. Well, that equals 3. So that one doesn't work. We'll try our only other option. Sub in p of 1. I get 1 cubed is 1, minus 3 plus 1. So you get 1 minus 3 plus 1. Well, that's also not 0. Okay?
It's also 3.
Yeah, negative, no, -1. Because you've got +1, +1, -3. So you've got +2, -3, -1. Good, but either way, neither of them are 0. So our only two options don't give us a factor. So it's not factorable by our means. So what do? Well, then we go to the calculator, or we go to Desmos. Solve using Desmos. Graph it
Are we ever going to have the opportunity to graph this Desmos?
to see roots. Oh yeah, lots of opportunity. Okay, if you did this on Desmos, you would end up with a graph that looks something like
that is a whack graph.
This. It's a pretty regular cubic here. And from the picture, you could look up your roots, which are here, here, and here. And Desmos will tell you that the solutions, or the roots of the equation, roots are x equals -1.9, 0.3, and 1.5. Okay, so when you don't come up with any, if it's not factorable, it doesn't mean that it never crosses the x-axis. It doesn't mean that there are no x-intercepts. It just means that you can't do it by hand with the skill set that you have. It means that you need to use technology, and it will give you non-integer roots. Good. Your practice problems for that come from page 110. Numbers 1 through 4 and 6 through 9.
Do you think we can close?